Question 2, 4 marks. Formula pack will be used on this one. A vertical pole stands on horizontal ground. The bottom of the pole is taken as the origin O of the coordinate system, in which the top F of the pole has coordinates 0, 0, 5.8. All units are in meters. The pole is held in place by ropes attached at F. One of the ropes is attached to the ground at point A with coordinates 3, 2, 4, 5, 0. The rope forms a straight line from A to F. Find the length of the rope connecting A to F. So in our formula pack, we're looking for the formula distance between 2 points in three-dimensional coordinate system. So we're looking for the distance AF is going to be the square root of, so the change in X, we've got 3.2 here, and that goes to 0. So 3.2 minus 0 is 3.2. We're going to square that. We're going to add that to the difference in the y values. So that's 4.5 minus 0, which is going to give us 4.5 squared. And then the last one is 5.8 and 0. So we're going to add 5.8 squared. Substitution into the formula, that's going to be a method mark at this stage. And then if we type this into the calculator, we're going to have square root 3.2 squared plus 4.5 squared plus 5.8 squared. Make sure that it brackets over everything, press enter, and we're going to have a value of 8.00812088, which is approximately 8.01 meters to three significant figures. Find angle FAO, the angle the rope makes with the ground. Okay, so now we just have to think a little bit differently. And what I'm going to do is I'm going to represent that through a picture down here. If I look at the flagpole looking down at the ground, I'm going to imagine that the ground is a flat area. The flagpole is somewhere on there. So that's my flagpole. There's a wire coming down. So there's my flagpole. There's a wire coming down, and the wire makes a shadow on the ground. So the angle FAO is this angle here. Okay. So when we look more at the information from, we've gone to, if we look at it like this, we can draw a right angle triangle. We have a difference in X of 3.2. We have a difference in Y of 4.5. And then we have a height of 5.8. So the first triangle that I'm really going to look at here is, again, a right angle triangle. We're applying Pythagoras' theorem because I want to find that the hypotenuse of that. Let's call it X. So X is going to be the square root of 3.2 squared plus 4.5 squared. And on the calculator, I'm going to cheat. I'm going to take that value, but I'm going to delete out those bits. So that gives us a length of 5.52. So 5.52. Now, reimagining our triangle F, O, and A, this length is now 5.52. We have a height of 5.8, and we're trying to find this angle. We have the opposite side, and we have the adjacent side. So we're looking at the trig ratios. The trig ratio in this case is going to be tan. So tan of, let's call it alpha, is going to be the opposite side, 5.8, divided by the adjacent side, which is 5.52. So this is part B. Alpha is going to be the inverse tangent of those values. And now we can jump to the calculator. We're going to type in trig. We're going to have 10 minus 1. We'll insert a fraction. We're going to have 5.8 over. I'm going to copy that value. And I'm going to paste it. So Control V. Actually, don't need that bit just to make sure. Okay, so just double check. Yep. Enter, which gives us a value of 46.4077 215 degrees, which is approximately 46.4 degrees.